Hello, boys and girls. We are here today ready for our next math lesson. So today we are looking at math lesson 21 of module 3. So for your materials today, you will need the lesson 21 problem set. I'll show you what that looks like. Looks just like that. We're working on some word problems today. And as they are word problems, you will also need a highlighter, okay, to highlight your clue words. And as always, a pencil. Okay, so your problem set 21, a pencil or a highlighter, and when you're ready, you can join me. Okay, so if we look at our objective and our I can statement for our lesson today, for lesson 21, it says we are solving two-step word problems involving multiplying single-digit factors and multiples of 10. Okay, we don't need to worry about that right there. We'll hop down to our I can statement. I can solve two-step word problems involving multiplication and single-digit factors. So word problems today, and more specifically, they are two-step word problems. So that just means we have a little bit more work to do. But if we just work through it carefully, we'll be just fine. Okay, so let's go ahead and pop over to our problem set for today. So go ahead and put your name and date on your paper and show me that you're ready to go. Okay. Our directions say that we're going to use the RDW process, and we actually say the RDWW process to solve each problem. Use a letter to represent the unknown. And just to review, RDWW, read, which involves our parentheses, our highlighting, our underlining, drawing a model to represent our thinking. The first W is to write a number sentence, and the last W is to write a word sentence. And that really helps us to kind of pinpoint what we're actually looking for, what we're solving. All right. And we're using a letter to represent the unknown. Okay, so let's go ahead and take a look at number 1. Will you put your finger, your pencil on there and just follow along with me, or you can read it right aloud with me. Okay, here we go. There are 60 seconds in 1 minute. Use a tape diagram to find the total number of seconds in 5 minutes and 45 seconds. All right, so let's take a look here. So 60 seconds in a minute. Did you know that? 60 seconds in a minute. We talked about that when we did our time unit too, so that should be a review for us. We want to use a tape diagram, so they're telling us the model that we're going to use to find the total number of seconds in 5 minutes, which we know that there's 60 seconds in a minute, so I'm going to put that right up here. So 60 seconds. I'm going to do /minute to kind of represent there's 60 seconds in a minute, and we're talking about 5 minutes, but then we have and 45 seconds. Did you see any clue words in there? I did. We'll see if you found the same ones as I did. 60 seconds in a minute, tape diagram to find the total number of seconds in 5 minutes and 45 seconds. Is that what you found too? Good. Alrighty. Let's look here. So we did our read. So I'm actually going to write RDWW right on the side there. And I'm going to check my R for the read. Okay, so now next comes the draw, and we know that we're drawing a tape diagram. Okay, and the first thing I want to ask ourselves is, do we know the total? We don't, right? Because it says we want to find the total number of seconds. So we don't know that total yet. So I'm going to kind of scoop it, and we don't know that yet. Okay, 60 seconds in a minute. Okay, use a tape diagram to find the total number in 5 minutes and 45 seconds. So there's 60 seconds in a minute, which we found there, and we're talking about 5 minutes. So if there's 5 minutes, how many parts am I going to put in my tape diagram if I want this to represent the minutes? For 5 minutes, 5 groups, so 4 lines, right? So 1, 2, 3, 4. And that gives me 1, 2, 3, 4, 5. There's my 5 minutes. And how many seconds are in a minute? 60. So I'm going to put 60 in each group here. So that represents my 5 minutes, right? But there's 5 minutes. I'm going to put a check mark there to show that I use that. I'm not finished with that yet, but I use that. And 45 seconds. So there's 5 minutes. So there's my 5 minutes. And 45 seconds. So I'm going to kind of put a separate little group here. And what do you think I would put in there? 45, right? To represent those 45 seconds. And there's that. Okay. And I also used my 60 to show that there's 60 seconds in a minute. So I've used my 60, my 5, and my 45. So now I just need to do the work to solve it. So there's 1, 2, 3, 4, 5 groups of 60. So what would I do to solve that? I have 5 equal groups with 60 in each. So I'm going to multiply, right? So it will be 5, because there's 5 groups, times 60 equals, and we want to use a letter for the unknown. So I'm going to say equals M, and then M equals. Okay. When we're solving a problem like this, since this is a multiple of 10, what I can do is I can hook the 5 and the 6 together, and I can multiply 5 times 6. What does 5 times 6 equal? 30, right? And then I can just add the 0, which gives me 300. So total, all these minutes here is 300. But am I done? No, because I have this 45 over here. So what would I do with this 300 and the 45? I'm going to add it together, right? Because it was 5 minutes and 45 seconds. So I'm going to do 300 plus 45. Do you know what that equals just by looking at it like that? Good. So 0 plus 5 is 5. 0 plus 4 is 4. And then we bring down the 3 and the 100. So it would be 345, 345 minutes, right? Because we're talking about a total number of minutes. Okay. And I can check off my draw. I can check off my writing of a number sentence. One more thing to do is to write a word sentence. So for that, I'm going to go back to my question or my task, use a tape diagram to find the total number of seconds. Oh, and you know what? That was that good thing I looked back at that, because we weren't talking about 345 minutes. We were talking about 345 seconds. So I just showed you in my own mistake why it's important to go back and read the question, because it helps us to kind of pinpoint what we're looking for. Okay, so find the total number of seconds. So there are, with a capital T, there are 345 seconds in 5 minutes and 45 seconds. There we go. Okay, so we had those 3 numbers in there, which is what made that a 2-step problem. We found the total number of seconds first in 5 minutes, and then we added that 45 seconds on after that. So not too shabby. Alrighty, you can pause it if you're finishing up, and then join me when you're ready for number 2. All right, put your finger, your pencil on Lupe for number 2 and read this with me. Lupe saves $30 each month for 4 months. Does she have enough money to buy the art supplies below? Explain why or why not. Okay, so this is definitely RDWW, right? Okay, and here's our art supplies below. So how much for the art supplies? $142. All right, so let's do the rest of our read and pull out our important information. So Lupe saves $30 each month for 4 months. So she saves $30 each month. I'm going to kind of break these two apart. So $30 each month. Do you see a clue word in there? Me too. What clue word do you see? Each. $30 each month. And each tells us that we're either going to multiply or divide, right? $30 each month for 4 months. So already I'm imagining my tape diagram, and I'm imagining 4 months would represent the groups. So I'm thinking 4 groups, and then how many in each group? 30. Good. So does she have enough money to buy the art supplies below? Explain why or why not. I'm going to highlight the word explain because that's important. Explain means we need to put some words down on our paper, right? A lot of times we kind of breeze right over that and we don't explain our thinking. So whenever it says explain, it wants us to explain our thinking. So we'll find the total amount that she has, and we need to figure out if she has enough for the art supplies below and then explain our thinking. Okay, so we already kind of talked about our tape diagram, right? So I'm going to check off that. So I'm going to draw my tape diagram. All right, do we know the total yet? Because we want to know, does she have enough? But we need to figure out how much she actually has, right? So $30 each month for 4 months. So since there's 4 months, I'm thinking 4 groups in my tape diagram. Are you with me? Okay. So if we want 4 groups, how many lines? 3. Good job. And then what are you going to put in each group? Go ahead and put what in each group, what you think is going to go in there. Did you put 30 in each group? Did you? Good. All right, what do you think our number sentence is going to be for this? Go ahead and write right down below or right next to it what you think our number sentence is that's going to match this. Think about what number would come first. Here's my thinking. 4, because there's 4 groups, times 30, because there's 30 in each group. Do you agree? Good. So do you remember how to solve a problem like this? Since this is a multiple of 10, 30 is a multiple of 10, I'm going to hook the 4 and the 3 together. And I'm going to say 4 times 3, 4, 8, 12. And then I just need to add on the 0 since it's a multiple of 10. And that gives me 120. So this, she has saved $120. And I can stick my dollar sign right in front. Remember, dollar signs always go in front of the money amount. All right. So she has saved $120. The art supplies cost $142. Does she have enough? No. So we need to answer that. So does she have enough money to buy the art supplies below? Explain why or why not. So we're going to say no with a capital N because she only has $120, but the art supplies cost $142. Again, remember that dollar sign goes in front. Even though when we say a money amount, we say $120 and $142, and it's after. When we say it, it comes after, but when we actually physically write it, the dollar sign comes before. All right, so we found that information that she had saved $120. That was our first step. Our second step to make this a 2-step problem was to compare it with the actual amount of the art supplies, which was $142, and then we had to make that determination. We could subtract to see how much more she needs. That wasn't the question, but you could definitely do that to push that even a little bit further. All right, so if you need to pause to finish up your sentence, you can go ahead and do that, and then let's look at number 3. Put your pencil on Brad and read with me. Brad receives 5 cents for each can or bottle he recycles. How many cents does Brad earn if he recycles 48 cans and 32 bottles? All right. Can I just tell you that my son Nick was saving bottles and cans for a long, long time, and he just took them in last week, I think, and he got $167 for all the bottles and cans that he'd been saving. So he was pretty excited about that. So now my daughter Ella is saving up all the bottles and cans. She says it's her turn now because she wants to make all that money too. So you could definitely make a nice little killing on saving bottles and cans like my kids did and like Brad is doing too. Okay, so let's solve this problem. So this is, and you know what? I forgot to cross all these off. Doesn't matter, but if you just kind of like to have them all done. Alrighty, so for number 3, we can get our RDWW set up, okay? Brad receives 5 cents for each can or bottle he recycles, so that's important, right? So he receives 5 cents for each can or bottle he recycles. Do you see a clue word there? I see the word each, which tells me that we're going to multiply or divide, right? So let's keep going. how many cents does Brad earn if he recycles 48 cans and 32 bottles? I want to bring your attention to this word, and. We don't think of and as a clue word, but when we see and between two amounts like this, 38 cans and 32 bottles, not two. I kind of highlighted over that so it smudged it. So he has 48 cans and 32 bottles. 48 cans and 32 bottles. What would we do with these two amounts to find out how many he has altogether? We would add. So that word and right there is actually kind of like a clue word that you're going to add those two amounts together to find out how many cans and bottles. Because if you recycle cans and bottles, if you take them in for money, you put them, they all go in a bag together, right? You take it all in a big garbage bag or a box, and then you take it to the store to turn it in for money. So we're going to add those two amounts together. So 48 cans and 32 bottles, we're going to add them together. All right, and then we know that he receives 5 cents for each of those. So we can check off our read, and next would be our draw. So, but I want to just bring our attention to, so if we look at the beginning, he receives 5 cents for each bottle or can he recycles. We don't know the total amount of bottles or cans he recycles, but down here it says 48 cans and 32 bottles. Normally, we've kind of been starting at the beginning. We find the information at the beginning that we can work with, and then we'll kind of work our way through. We can't do anything with the 5 yet until we kind of figure this out down below, right? So this is where we're going to start for this problem. So we're going to add, like we talked about, 48 and 32 to find the total amount of bottles and cans that he's recycling. So 48 plus 32, you can go ahead and solve that. You can pause it. Okay, I'm going to solve it and see if you agree. 8 plus 2 is 10, 0, carry the 1. 4, 5, 6, 7, 8. 80, thumbs up if you also got 80. So he's recycling 80 bottles and cans. So he has quite a few. And now we know that he's receiving 5 cents for each bottle. So I can check off 48 and I can check off 32. And he receives 5 cents for each bottle or can he recycles. So if I'm going to think of a drawing here, so there is 80 bottles and cans. Do I want to, and they're 5 cents each, do I want to make a drawing of 80 groups? That's a lot, right? So we know there's 80 bottles or cans, and each one would be 5 cents. So instead of making 80 groups of 5, can you think of another way that I could make that drawing? Instead of making 80 groups of 5, could we use the commutative property to solve that? Flip-flop, right? So instead of making 80 groups of 5, could I make 5 groups of 80? Yes, right? That's how properties like that can really come in handy. So I want 5 groups, so 4 lines. So 1, 2, 3, 4. And then check and make sure you have 5 groups, 1, 2, 3, 4, 5. And remember I said I'm going to put 80 in each one. So instead of making 80 groups of 5, because that would represent our picture or our problem, right? 80 bottles and cans and 5 cents each. I'm going to use the commutative property and I'm going to flip-flop the 80 and the 5. So instead of saying, because it really would be 80 times 5, but instead of doing 80 groups of 5, I'm doing 5 groups of 80. And then I can solve this. So do you remember how to solve a problem like this? Since this is a multiple of 10, I can hook the 8 and the 5 together. What does 8 times 5 equal? You can count by 8s, or you can count by 5s. 5, 10, 15, 20, 25, 30, 35, 40. So it equals 40. And then what do? I just add that 0 since it's a multiple of 10. So it equals 400. So right there, I've got 400. So 400 what? I look back at my question. How many cents does Brad earn if he recycles 48 cans and 32 bottles? Do you know what to put? We could write the word cents, or we could also write a cent sign, which looks like this. And the cents comes after. So the dollar sign comes before the money amount, and the cent sign comes at the end. Okay, so let's see. We did our draw. We wrote our number sentence. We didn't use a number to represent the unknown, but you know what? I'm okay with that because it's a 2-step problem, which is a lot of work. So the important work is that we're getting it. If when you work on this on your own, you use a letter for the unknown, perfect. But I'm I'm not worried about it, okay? The last thing we have is our word sentence. How many cents does Brad earn? So Brad, with a capital B, Brad earns 400 cents, period. Okay? And if you need to pause to finish up, go ahead and do that. And if not, go ahead and turn it over. All right. We're not going to do all of these on the back because I feel like we've been working really hard. So let's see. Let's cross off number 4. And let's cross off number 6. And we'll have one more to do. How does that sound? Okay. So let's look at number 5. So this is definitely RDWW, right? Is this a 2-step problem? Take a look. Yes, because I'm looking and I see 3 and I see 18 and I see 12 and I see 49. We have 1, 2, 3, 4 numbers, which means, and unless it's asking us to find the total of all the numbers, it's going to be at least a 2-step problem. So it definitely, if it says to find the total of all the numbers, then it would just be a 1-step problem. But since it's not saying that, if we look at it, it's not asking just for the total of all of them. It would definitely be a 2-step problem to work it through. So let's go ahead and do our read. So put your finger, your pencil on Mr. Perez. Here we go. Mr. Perez buys 3 sets of cards. Each set comes with 18 striped cards and 12 polka dot cards. He uses 49 cards. How many cards does he have left? So let's start at the beginning. So he buys 3 sets of cards. So I'm thinking of my tape diagram and I'm thinking 3 groups to represent the 3 sets. Do you think so? So train your mind to, like, when you read it, to think of a picture in your head as you're reading it. Each set comes with 18 striped cards and 12 polka dot cards. So each set comes with 18 striped cards and 12 polka dot cards. Do you see anything in there that you want to bring attention to? Like we talked about the other problem? There's 18 striped and 12 polka dot cards, and we would want to find the total amount of cards in each set. So what is this and telling us that we're probably going to do? Add, right? We want to add those 18 striped cards and the 12 polka dot cards. He uses 49 cards. So that's how many he uses of all those cards. And we want to know how many cards he has left. Do you see another clue word? Left. Do you remember what left tells you? We're going to subtract, right? So if you are using some, okay, if we use some, they go away or they're being used, and we want to know how many he has left. That means we're going to subtract. So if you think of like chocolate milk, so let's say the 5 kids each had a glass of chocolate milk. How much is left? That means that if they drank some chocolate milk, it's going away, and we want to know how much is left. So since some went away, we want to know what's left. That means that we're going to subtract. Alrighty, so there is our read. So let's do our draw. So 3 sets of cards. So we kind of talked about already that we were imagining a tape diagram with 3 groups. So 3 groups, that means 2 lines. All right, so each set comes with 18 striped cards and 12 polka dot cards. There's a couple ways that you could do it. So each set has 18 and 12 right in it. So you could put both of those numbers in it, but we want to find the total. We already said we're going to add those 2 together. So let's do 18 plus 12. Go ahead and pause it and find that total for me. Okay, 8 plus 2 is 10. That makes a 10, so 0, carry the 1. 1, 2, 3. So that equals 30. So that means when I added these 2, that equals 30. So what's going to go in each of these groups here? 30. So what would my total be for all of these? I could do, there's 3 groups times 30 equals 3 times 3 equals 3, 6, 9, and then I just add the 0, right? Or I could say 30, 60, 90, as long as we come up with 90 for that. Am I done? Okay, so I know that he has 90 cards. Okay, so let's look. I used the 3, I used the 18, and I used the 12. Did I use all my numbers? He uses 49 cards. How many does he have left? Remember, we highlighted that clue word left, which was telling us that we would subtract. So we said that he has 90 cards and he uses 49. What am I going to do with this 90 and that 49? We already decided that we're going to subtract, right? That was signaling to us that we were going to subtract. So 90 minus 49. 0 minus 9 isn't 9. No, I'm trying to trick you. We can't do 0 minus 9, right? So I'm going to go to the tens place. I'm going to cross out the 9 and make it an 8, and the 0 becomes a 10. 10 minus 9 is 1, and 8 minus 4 is 4. So how many cards does he have left? 41 cards. Okay, I just put that so we can kind of see that this one is our actual answer there. So we did our draw. We wrote a couple number sentences. Again, I didn't use a letter to represent the unknown just because we already had so much going on. But if you want to do that when you're working on your own, feel free. We need to write our sentence. So how many cards does he have left? So he has, make sure we have that capital H. He has 41 cards left. What goes at the end of our sentence? Period. Okay. Whew, and there we have it. So we actually, let's look at our steps there. So we had 1 with our tape diagram, and we had 2 and 3. We had 3 steps, right? So we had our tape diagram. We decided that 30 went into each one. Then we found that 3 times 30 was 90. And then we did 90 minus 49 was 41. So yeah, we did a lot of work there. But if we kind of break it up and do a little bit by little bit, it's not so bad, right? Okay. So if you want to, if you stayed with me for all of that, because it was kind of the 2-step problems, it was a little bit more today. If you want to try 4 or 6 on your own, that's certainly okay. Just remember everything that we talked about and checking off each number as we go in a 2-step word problem or a 3-step word problem is a good habit to get into when we're first learning how to really break these problems apart. Okay. They can be tough, but if we kind of break it up and work little by little, we can definitely do it, and it helps make it a little bit easier. Okay. All right. Super job, kiddos, today. We really tackled these 2-step word problems, and I will see you tomorrow.